Tonight, before I begin, I'd like to remind you that if you carry a handheld device, that perhaps if you could set it to some mode where I can't hear it, that would be really terrific. Well, thanks very much for coming out tonight. My name is Sam Wong, and I'm Chair of Public Lectures, and I really appreciate seeing you all tonight. This is going to be a very exciting talk, and I'm really looking forward to it. It's a real pleasure to host this latest talk in the Lewis Clark Van Uxem series, which is co-sponsored by the Department of Molecular Biology and the Committee on Public Lectures, and I'm affiliated with both of those organizations. Lewis Clark Van Uxem was a member of the class of 1879, and this is a series that was founded in 1912 on a bequest from his estate. And this is a series that has continued for many years. Van Uxem made the bequest to support lectures on subjects of a scientific nature, and previous speakers, just to give you a flavor of the talks in this series, have included Edwin Hubble, Alfred North Whitehead, Robert Oppenheimer, Linus Pauling, Freeman Dyson, Nancy Hopkins, Antonio Damasio, and well, I think that's enough. And so it's really been exciting to follow the history of these talks over time. Tonight, our speaker will be introduced by my colleague, Professor William Bialik. Professor Bialik is John Archibald Wheeler Battelle Professor of Physics and Associate Director of the Louis Sigler Institute for Integrative Genomics.
So it's a slightly complicated ritual in which eventually you get to hear Marcello. Tonight, we're going to be transported back in time, both through the evocative power of the words of a great writer and through the power of mathematics and physics, which allows us to extrapolate backward to the events of this period. But before we start, I wanted to take you back, just for a moment, 50 years. Almost exactly 50 years ago, a little bit before Marcello and I were born, but that's not the reason. It's 50 years ago that C.P. Snow gave a famous set of lectures called The Two Cultures, in which he emphasized the divide between the sciences and the humanities, and in particular, between the sciences as exemplified by the mathematical and physical sciences. So we all have grown up in the situation that Snow described. In the academy, the humanities, the classical literature, which is the motivation for tonight's talk, and the mathematical sciences are not only taught in different departments. Our department chairs typically answer to different deans, which gives some sense of the scale of the division. It's seldom that we have a chance to bring these different cultures together, and so tonight is a cause then for some celebration. Our speaker is, in addition to having done this, which he's going to tell us about, and thus providing this occasion to celebrate the bridge across disciplinary divides, is, of course, a tremendously accomplished scientist. He's professor of mathematical physics at the Rockefeller University, where he's been now for some years. He received his PhD from the University of Chicago, where he was much decorated. Spent time as a postdoc, both at Rockefeller and at the NEC Research Institute, where I first knew him. Marcello has worked at the interface between his day job, as it were. This is an avocation that he'll share with us tonight, is on theoretical problems at the interface between physics and biology. And this is an area which has been one of great activity over the generation that spans his own career, and I think it's fair to say that Marcello has been one of the most persistently creative contributors to the field, having taught us about problems ranging from the molecular events responsible for motion inside cells to understanding the pace of evolutionary change, to thinking about why our ear is as frequency selective as it is, how it's possible for us to distinguish the subtleties of tone and harmony. It's a remarkable breadth, and his work has been sort of every few years something comes from him which surprises all of us. And it's been a pleasure to know him over this period, and it's a pleasure then to share with you what he has to say about the Odyssey. So, Marcel.
Thank you, Bill. Let's go for a second somewhere. Just a second. Okay, so now we're started. So many thanks. I can't begin to tell you how excited I am to be here today. This has been, as Bill said, an avocation. It has taken many years of playing around with this stuff. It started literally as a very private investigation with my co-author Constantino Vaikosis, and eventually it was a roller coaster ride until today I'm here at a major conference in Princeton describing this stuff. So I would like to thank the organizing committee for the invitation. I would like to thank Bill for a consistently embarrassing introduction, and I'd like to thank you for coming. And in particular, in addition, I would like to tell you that today is the birthday of my co-author Constantino Vaikosis of the National Observatory in La Plata, Argentina, and so I would like to dedicate this lecture on occasion of his birthday. So let me start. I would like to state up front what I'm trying to achieve tonight, okay? And I'm going to be walking you through a controversy, a very minor controversy, that has simmered far below the radar for some 2,000 odd years, and that concerns the historicity of certain events that, if they were true, they would have happened about 3,200 years ago. I do not expect you in any way to take sides. Quite on the contrary, I would like you all to remain healthily skeptical of both sides of this debate, and I hope that you realize that there are excellent arguments on both sides of the discussion. What I do want is for you to go back home and pick up your copy of the Odyssey, preferably the local favorite, Feigel's beautiful rendering, and read it again and think. That's what I want you to do. Go pick up the Odyssey again, read it again, and think. And think that maybe, have the thrill of experiencing at least one reading of the Odyssey in which you think that maybe when he's talking about a rosy-fingered dawn, he's not actually using just a formula, he's really telling you about a sunrise that actually happened once. Okay? The controversy concerned originally a very peculiar passage in the 20th book of the poem. It's the fateful day in which Odysseus will slay the suitors. He has already come in to his halls disguised as a beggar. He has spent the night awake, plotting murderous revenge. And when morning comes, he asks Zeus for some sign, and thunder rumbles in the clear sky. And then the palace is abuzz with the celebrations because it is the feast of Apollo, and just as the suitors are sitting down for the noontime meal, Athena confounds their minds, and the seer Theoclymenos makes a very remarkable speech. He says that the sun has been utterly obliterated from the sky, and an unlucky darkness spreads all over the world. And these words have been interpreted by many for 2,000 years as describing a total solar eclipse. And some people have gone as far as to posit that maybe it's not just a poetic rendering of a total solar eclipse, that the words describe an actual eclipse that indeed happened. And if that eclipse indeed happened, chances are that it is this particular eclipse I'm telling you about here. Do I have a pointer? I can point with the mouse, but I don't know if you can see it. Okay, it's this particular eclipse over here, April 16, 1178 BC, close to noon at the local time of the Hawaiian Islands. Okay, this eclipse was utterly spectacular, and whoever witnessed it must have passed it on to later generations rather vividly. Let me show you further. Okay. On an arc in the sky, everybody can see the eclipse? On an arc in the sky at about that angle and about that size, you could see the sun, or the corolla of the sun that's left, surrounding the, the ring surrounding the moon, Saturn, Jupiter, Mercury, Mars, and Venus simultaneously in a little arc on the sky. Okay, it's very rare that you would get to see all of the naked eye planets simultaneously on the same side of the sky. You would see then the most beautiful of all of the constellations, according to Homer, the fair Orion, the hunter, really the largest and most recognizable of all of the constellations, and the faithful dog of the hunter, the star Sirius, which is the brightest star in the sky. It's just hovering above the horizon. Okay? It's unlikely that you would have been able to see the Pleiades, which are way too close. We are way too close to the corona. During this eclipse, at the height, if I move away from the microphone, nobody hears me, right? During the height of the eclipse, the darkest phase of the eclipse, the total brightness of the sun would have been obscured to be no brighter than a full moon. But even then, if you have a full moon, it would be very hard to see a star very nearby, but you could definitely see the rest of the sky. Okay? So this was, a remarkable eclipse, and let's go back to Homer. This was a remarkable eclipse, and we're going to come back to exactly how it comes up in the Odyssey. So what I'm going to tell you today is going to be treating a very delicate boundary between daring to say something and being cautious about what is being said. And so I think that there are two quotes that embody both sides of this boundary. The excitement of actually looking at this is embodied by the words of Gilbert Murray, famous classicist at Oxford, who said that, now, when did Odysseus return to Penelope? The date is given with a precision most unusual in epic poetry. And this is what I'm going to try to convince you, that indeed the date of the return of Odysseus to Penelope is given with a precision most unusual in epic poetry. Okay? But we have to be very careful, because this is the Odyssey we are talking about, and there is the second quote that allegedly was originally one of these exam time blunders collected by professors, but it has been taken up as sort of the manifesto of what the Homeric problem really means. The Odyssey was not written by Homer, but by another man of the same name. And this is true, okay? Whoever we think Homer was, that wasn't Homer. It was somebody else. Okay, we know extremely, remarkably little about the author of these two most beloved poems in the literature. Okay, so we have to be very careful about what we say and how we interpret it, even as we, try to get some excitement. So the paragraph in question, the Theoclymenos prophecy, this is the gifted seer Theoclymenos, and there are the lines. You're going to be seeing 1,000,000 different renderings of the same line in different translations, okay? So this is Feigel's translation, and you'll see that he says, the sun is blotted out of the sky. Look there. A lethal mist spreads all across the earth. Now, there's a 2,000-year-old idea that says that this is a poetic description of a total solar eclipse. And critics of the idea note that the problem is that it's not really a convincing description of an eclipse. The passage is not outdoors. The passage takes place indoors. They are in the Megaron. Nobody other than Theoclymenos actually sees the eclipse. So there is some contention as to whether it actually describes an eclipse, and in fact Dennis Page went so far as to declare the whole set of lines spoken by Theoclymenos to be apocryphal, a later addition, because he claimed that it was a character that was completely out of place. He did nothing of note other than give this speech. Of course, if we believe that by giving this speech it's giving us the date of the Odyssey, then he is doing something of note. Okay, but the passage in question has been criticized as not being a sufficiently convincing description of an eclipse. I'm going to come back to that. Now, if you believe that there is cause to dispute whether this could be a description of an eclipse, then you will have much more cause against this idea, 400-year-old idea, in which you say that the passage actually describes a specific eclipse. Not just an allegorical eclipse for the poetic purpose of, describing the entrance into Hades of the suitors, but that it's actually describing an actual eclipse that maybe Homer received in the legend the statement that the day the king returned there was a total solar eclipse, and that that should allow you to date it. And indeed, if there is an eclipse, the eclipse was dated in 1926 by Carl Shaw, who showed that the only reasonable candidate for this eclipse is the one we just saw, April 16, 1178 BC. Now, critics of this idea say that now matters are much worse, because you see, Homer is writing some 400 to 500 years after this particular eclipse. And how could he, know about when exactly it happened? How could this be transmitted in any reliable way during a period in which it is widely believed and understood that the Greek had become almost entirely illiterate? It would have had to be just some oral transmission that there had been an eclipse. So this second idea becomes even more unlikely than the first one, and that's where the funny things comes. We go even a step further, but then the idea doesn't become more unlikely. Our idea, our statement is that there are many passages, not just one, many passages in the Odyssey that set it on one specific date. Or, well, one date per day, evidently. And the eclipse is only one of these references. This idea subsumes ideas by various writers, such as Gilbert Murray and Norman Austin, that the season of the Odyssey is an integral part of the storyline. I'm going to come back to that. Okay. What is the season in which the Odyssey takes place? Which time of the year is it? It is indeed a part of the storyline. So if it is true, yeah, I should clarify the meaning of the word set before people interpret it in a way I don't want. Set should be understood in the same way as saying that James Joyce's Ulysses is set on June 16, 1904. Okay? So there are passages in the work that allude to specific dates. That is not, you know, if you read Joyce's Ulysses, there is no question that you are being told what the date is, and you're being told that the events take place in Dublin. Right? That is not a reason to infer the historicity of Stephen Dedalus. All right? We cannot infer much from saying that something is set on a certain date. The writer, in his mind, is giving us details of the time where it is happening, but it doesn't mean that we know even that the writer believes this to have happened. It could be entirely fictional and still be set. Okay? So I want to be very clear about this. Our analysis cannot penetrate past that boundary. Okay. The specific date in question is therefore datable by references other than the eclipse, and therefore we can avoid all of these problems with Theoclymenos' prophecy. Why we come back with a crazier idea after the, you know, apparently saner ideas have been debunked? Well, because of strength in numbers. By having many different passages that allow us to date independently the work, we can then compare if all of this is consistent, which is something that we couldn't conceivably do if we are only looking at one single passage. So, the 2,000-year-old idea. Plutarch, in De Facie Orbis Lunae, is talking about eclipses, and he is describing the requisite eclipse for a total, the requisite time of the month for a total eclipse of the sun, which is that it has to be a new moon. You see, if the sun is going to be behind the moon, then evidently the moon must be new, because it's illuminated from the back instead of from the front. And stating this truth, he says, and to crown all, he will cite Homer, who says, the faces of men are covered with night and gloom, and the sun has perished out of heaven, speaking with reference to the moon, and hinting that this naturally occurs when waning month to waxing month gives way. So Plutarch is the first to note that Homer insists in various passages before the passage of the eclipse that it is a new moon. Okay? It's not once but 3 times that he gives very solid statements that the time of the month is the new moon. And this is sort of uncharacteristic in epic poetry. And then he has this beautiful paragraph, I can't resist but reading it. For the rest, I think that it has been reduced by the precision of mathematics to the clear and certain formula that night is the shadow of earth and the eclipse of the sun is the shadow of the moon. Okay? So at night it's dark because the earth is between us and the sun, and we are on the shadow of the earth. And during an eclipse it's dark, not because the earth is casting a shadow, but because it is the moon that is casting a shadow. And Plutarch goes so far as to say that this proves that the earth and the moon are made of the same stuff, because both can cast shadows. It's a phenomenally beautiful statement. Heraclitus the allegorist goes on with a similar observation, but his observation is interesting. He goes on to separate the observations about what happens during an eclipse, namely, as an eclipse is starting, nothing happens for a very long while, then you see the light turning reddish around you. And then when totality comes, the only light available is the light of the corona of the sun, and that light is very, very high temperature bluish. And so the way people who have seen this describe it is the faces of people look completely exsanguinated. They look like gulls in this very, very bluish light. And Heraclitus first goes on to notice that Homer goes out of his way to describe everything covered with blood, everything reddish. And then he points out that he is also very scrupulous about showing when the eclipse actually happens. One moon waning, another one waxing. This is actually another rendering of the same verse. And such is Homer's precision about the eclipse, covering both its concomitant circumstances and its timing. Okay. So the ancients were utterly convinced that Homer was describing an eclipse. They say nothing about a particular eclipse, they just say that this is an eclipse. In order to add a little bit to this, let me point out the observation of my friend Constantino, who pointed out to me that the word Homer is using to describe the eclipse, epidedromen, which people variously translate as invade, run over, or spread all over the world. This word actually has the connotation of a very rapid surprise attack, as befits all of the definitions in the standard Greek dictionary. And this is so because of the following interesting phenomena in an eclipse. This is a plot we've made of the magnitude of the sun as a function of the time since the disk of the moon makes first contact with the disk of the sun. So this is the first contact. There is literally no eclipse, they just touch. And as time goes by and you approach totality, the amount of light that you get is essentially the same as you had originally. Even when half of the sun is covered by the moon, even then, half of the sunshine is a lot of light, and you do not see anything changing. So the magnitude of the light, which is for regular sunshine at -26, goes on and on and on as being exactly the same magnitude, and then in the last few minutes there is this abrupt change. And it's only literally in a matter of 1 or 2 minutes in which all of the light is lost, and the sun that was extremely bright before all of a sudden acquires the brightness of a full moon. And then all of a sudden you're seeing stars. Okay? And it's very, very rapid. And people describe it as, literally feeling like an attack. It just sneaks up upon you and poof, the light goes off. As this happens, various other things happen that people find very ghoulish. So the temperature drops several degrees in seconds. The birds are terrorized and they literally drop off the sky. The birds literally throw themselves on the ground. The animals become restless, and people generally freak out. Okay, it's like an all-down attack. So the word that Homer is using is extremely appropriate to a description of an eclipse. 400-year-old idea. So in 1921, Fotheringham, who is the father of the modern science of historical eclipses, gave the Halley Lecture. And in the Halley Lecture, he describes a number of historical eclipses used to date various episodes and chronologies, and he mentions the eclipse of Odysseus. And he mentions everything that we have covered already, so that's not relevant. Let's move down to the last paragraph down there. I'm not sure if it's quite legible. Herwart von Hohenberg, who was a very close friend of Kepler, in 1612 went so far as to date the return of Odysseus and the Trojan War by means of the eclipse. This was a valiant, though fated attempt. Von Hohenberg was not in a position to actually have the elements of the moon's motion that will allow him to date an eclipse so far before his time. But, it was a valiant attempt to do so. He dated it in 718 or something like that. And then Fotheringham concludes, I suspect that the eclipse was in the legend as Homer received it, but I am not prepared to use it to date the Trojan War. So Fotheringham chickened out of the controversy, even though he kicked the ball. But 5 years later, his disciple Carl Shaw actually did date the return of Odysseus, and he describes how he computes the elements of the lunar orbit to be able to date the eclipse, and then at the end he restores the chronology by saying that the slaughter of the suitors takes place in -1177 is astronomical notation for 1178 BC. If you are talking about AC or BC, you don't have a near zero, but astronomers can't tolerate not having a near zero. So the negative numbers in astronomy are minus a number which is one less than the corresponding number in BC, so don't be confused. So the slaughter of the suitors takes place in 1178 BC, April 16th, and therefore the fall of Troy would have been 10 years before that, in 1188 BC. This is the path of the eclipse that Shaw computed. It starts somewhere in Russia, it goes down. The shadow of the moon on the Earth at any given time is a very small disk, approximately 200 to 300 kilometers in size, and as the motion of the moon progresses, this shadow keeps moving down on the Earth. It goes through through Greece and the Ionian Islands, and then it makes landfall again in Africa, somewhere near Tripoli. Now, I should be very clear to you that even today we do not have enough accurate data to place this track very precisely. Namely, the error we have for the position of this track is approximately the size of its own width. So conceivably it could be moved either to the right or to the left by an amount equal to its width. Okay? In fact, since our paper was published, I believe that the NASA revised the elements so that now the track should look like the Ionian Islands, which are there, should be on the left side of the track as opposed to the right side of the track. Okay? Now, the interpretation of the eclipse, as I said before, is challenged on both literary and historical grounds. Okay? Literally, the scene, as I said, does not make a lot of sense. Historically, there is a lot of problems with saying, you know, this guy is describing by oral tradition something that happened 5 centuries before his time. It's like us today describing by oral tradition the discovery of America. Okay? It's very unlikely to think that in the absence of documents, in the absence of writing, any much detail would be preserved. So we'll come back to that because it's still a hurdle. So what we did, I'm going to tell you now, is written in a paper. The paper is by Cosis and Magnasco. It's Proceeding of the National Academy of Sciences last year. It's an open access paper, so anybody can access it without a subscription. And I have a stack of copies here somewhere for anybody who wants a copy of the paper. Okay? So what we did was to use the other astronomical references. Okay? Let me remind you for a second of the structure of the Odyssey, because not all of you would, have read this in the last year or two. The Odyssey is actually a rather complex piece of literature. It's layered in a very interesting manner. We are open in the middle of the action with the hero at the bottom of his fate. It's called In Media Res, and there is a foreground narrative in which an impersonal narrator tells us of the 40 days since Athena goes to the Council of the Gods to plead with her father that he let Odysseus go back home, to the day after the death of the suitors. 40 days elapse. Within those 40 days, we are told the story of the 10 years before in various flashbacks narrated by the characters in the story to other fictional audiences within the story. Okay? So various characters like Nestor, Helen, but mostly Odysseus himself, narrate various pieces of the history of what happened before. Now, I would like to point out that all of the funny, fantasious, extravagant stories of the Odyssey that we vividly remember from childhood, all of these happen in this second layer. All of them are hearsay. Okay? All of them are the words of somebody within the Odyssey addressing somebody else. And the worst of these, of course, is Odysseus, a character vividly described as never opening his mouth without lying. Okay? There's no, his father is already described as being a master at thieving and cursing and lying. And he never in the Odyssey addresses somebody he doesn't know and says the truth. He systematically lies. And then he's there trying to tell an audience how he came to lose all of the soldiers that came with him to the war of Troy. Okay? And he tells them, of course, a Cyclops ate them. Okay, what's he going to say? Right? So, I want to be very clear that there is this second layer of wildly, fantastic stuff in the Odyssey that is not at all our concern. Okay? It is technically hearsay. They are not events that we are looking at. What we are looking at is this foreground layer, everything that's narrated by the impersonal narrator, and in that layer, interestingly enough, there are exactly 5 supernatural beings. There's Athena, Zeus, Calypso, Hermes, and Poseidon. Okay? Of these 5 supernatural beings, none of them does something really extravagant. Athena pops out and in, but she is some personification of fate. Okay? She is the one that's making things happen, but things happen, right? So that's the way, So Athena is the god that makes things happen. Zeus is there on high, authorizing things. And Calypso lets Odysseus go without any further ado. There's nothing supernatural about that. Hermes and Poseidon have very limited roles, and both just move from one place to another, do something, and then vanish from the story. Okay. So the interesting thing is that Athena is popping in and out instantaneously. She doesn't need to travel anywhere. She just pops in and out. Zeus and Calypso never move. And Hermes and Poseidon move once. And that's it. Okay? This is going to be important. So, we're going to be taking 4 specific references. As Odysseus sets sail from Ogygia, he navigates by the star. There's a remarkably beautiful paragraph in which we are told how Odysseus sets sail and how he navigates to go back home, which stars he looks at, and how he steers by them. This paragraph is extremely important because it tells us the precise month of the year he's traveling and in which direction he's traveling. Before landing in Ithaca, Venus is described as being very high in the sky, very early. Okay? There's a lot of action that happens between the lines in which the sailors spot Venus in the sky and the moment that dawn breaks out. There's a lot of things that happen, so Venus was very high and early that day. The day of the massacre of the suitors is, as we have already described, we are told at least 3 times that that day is a new moon. And finally, I'm going to use the reference of Hermes as describing a motion of the planet Mercury. And this is sort of controversial, this is not entirely established, but I'm going to be taking this hypothesis and run with it, see where it takes us. And so Hermes is sent to Ogygia, he goes all the way west, says his piece and returns, and I'm going to be taking this as a motion of the planet Mercury going all the way west and returning. Okay? It's important to note that all 4 of these motions have incommensurate periods. The first reference is a reference to the positions of the star in the sky at a specific time at night, and this changes yearly in what is called the tropical year. The second one has to do with the period of Venus. The third one has to do with the period of the moon, which is incommensurate with the year. The number of moons that fit within 1 year is not an integer number. And finally, the last one has to do with the period of Mercury, and all of these 4 periods are non-recurring. And this is what's going to allow us to use these references to find the date. This is a chronology of the Odyssey. There's a classic chronology by Delebecq that we have turned upside in because we are interested in dating starting with the date of the massacre of the suitors. So we are going to call that date date 0. And we're going to number our days backwards rather than forwards, because this is really the culmination of the action and where the day we're actually trying to place, because this is the date of the eclipse. Okay? As we do so, we run into a little issue called Zielinski's law. In epic narration, the tradition is never to narrate simultaneous events as taking place simultaneously. You narrate them as though they take place consecutively. And so it is too much confusion of people who take the Odyssey for the first time that there's a council of the gods where Zeus agrees to something, 5 days elapse, and then we have another council of the gods on which Zeus agrees again to do the same thing. What happens is that we are being narrated consecutively things that take place simultaneously. Okay? If we keep track of the sequential or the parallel days, if we number them from the massacre of the suitors, no much problem happens, because all of the problem is at the beginning in the voyage of Telemachus. So I'm going to keep the sequential dates because these are the ones as described in the Odyssey. These are the Zielinski law days. But the other days, the days you infer to be the parallel days, really there's no much problem. They don't differ by more than 1 on any single occasion. Okay? I should tell you what my search range is. Of course, if I describe an unlikely event and I went for a sufficiently long time, that unlikely event can happen arbitrarily many times. Therefore, I have to choose a search range that doesn't prejudice the idea that the thing has to happen. So I chose the largest search range I could get away with. And we did this by looking at the following. We looked at the classical estimates for the date of the fall of Troy. We find the range there. We add 10 to that to account for the time it took Odysseus to go back home. And we're done. So this is the spread in the classical estimates: 1131 BC for Ephorus, 72 for Solsibus. These two are the most important: 1184 by Eratosthenes and 1193 for Plato. And then 1208 in the Paleochronicles, blah blah blah, and Duris that gives 1333. That's completely out of range. So, in addition, the most likely candidate for Homeric Troy is the layer of Troy that's called Troy 7a. Troy 7a was destroyed by fire, and the remnants of that destruction by fire have been dated to approximately 1190 BC plus minus 2 years. So that would fit the date of the eclipse just fine, which would be 1188. Also notice that the date of the eclipse would fall square, within the date of Eratosthenes and that of Plato. So if I take away from this list Duris' estimate, and I recognize that all of these dates are themselves subject to uncertainty in ancient chronologies. I mean, this is our modern interpretation of what the writers were saying, but it's not necessarily true. So it could, those dates could still be wrong. So we add 10 years on each side to get finally a range of 1250 BC to 1115 BC, a range of 135 years. In those 135 years, there were 1684 new moons. We enumerated every single one of those new moons, and we call the date of that new moon T sub I in mathematical notation. Then we go back to our little chart, and we demand for each new moon, on T minus 5, was Venus high in the sky? On T minus 29, were the stars as described in the star passage? On T minus 33, did we see Mercury? And so we make a little table and we start striking out every single new moon that doesn't satisfy this criteria. Let me tell you exactly how we do this. These are the passages of the new moon. There's one interesting thing about the new moon I should tell you before I dismiss the subject that has not been noticed before. On day minus 29, Calypso finally gives Odysseus her leave to go back home. So Odysseus has been Calypso's sex slave for the past 7 years or so, and finally, reluctantly, she lets him go because Zeus demands it. And she does that with a good heart. She says, okay, fine, you go, I'll help you build a raft, I'll give you my blessing. And Odysseus sets off at sunset on day number 29. And as he sets off, he spreads his sails and looks at the stars. And notice that that day, to the day of the death of the suitors, it's exactly 29.5 days, exactly one moon. There is precisely one moon between leaving the embrace of Calypso and embracing Penelope. Okay? This is also important because there is another passage the night before on which we are told that the night was dark and there was no moon. Okay? Which is, adds to the number of passages telling us that this is a new moon. If it was new moon on day 0, it would have been new moon on the midnight of day 29. So, and this is the passage. The wind lifting his spirits high, royal Odysseus spread sail, gripping the tiller, seated astern, and now the master mariner steered his craft. Sleep not waiting on his eyelids is the passage as I recall it. Forever looking at the stars, the Pleiades and Bootes, or the plowman. Late setting Bootes is the text, what the text says. And the great bear that people also call the wagon, who circles on her axis ever fixed, watching the hunter, and who alone is denied a plunge in the ocean's bath. Hers were the stars the lustrous goddess told him to keep hard to port as he cut across the sea. Now this apparently completely enigmatic passage is something that would have been clear to virtually everybody in Homer's time. Everybody knew these particular stars. They were the basis of their agricultural calendar, they were the basis of their navigation. We read this passage today and we are so deprived of being out in the open looking at the stars that we cannot make sense of this. But those people could. Okay? And I want to emphasize this, because indeed there is not a single extant translation of the Odyssey, not even Fagles, I'm afraid to say, that has a footnote to this paragraph that actually gets it. Okay? Even though these stars and these constellations are the ones that appear in Hesiod, the only contemporary of Homer that has survived today. Okay? Now, the Pleiades and Bootes are almost 180 degrees apart in the sky. If you knew your stars, you would know that. So if they are almost 180 degrees apart in the sky, actually 165, it's very rare to see them both. So if you are going to be seeing both the Pleiades and Bootes at the time of nautical twilight, which is when you set off to begin navigating at night, it must be a specific time of the year at which this happens. Okay? We're going to see which time of the year this happens in a second. But this is very clear. These are very recognizable stars, and they are far apart. Okay? Then we're told that Odysseus is told to look at the Great Bear and keep her on his left. Now, the Great Bear was the northernmost constellation in the sky back then. It was the closest thing, the closest visible constellation to the North Pole. The skies have shifted since the times of Homer. And Polaris, which today is our North Pole star, was nowhere, immediately near the pole. Okay? Kochab was the closest thing to a North Star there was back then. The Bear was up there, circling ever in the sky around the North Pole, and never plunging in the ocean. Okay, never going below the level of the horizon, because it was, back then, it no longer is, a circumpolar constellation. Okay, so you have that over there, and it's signaling north. The Bear is signaling north. So when Calypso tells Odysseus to keep the Bear on his left, he's instructing him to sail due east. Let me show you how actually seeing these things would change March 1. Here I have the sky, and as it would have been seen at the latitude of assuming the paragraph is correct and he's traveling due east, this is the same latitude as Ithaca. And this line over here is the horizon. Okay? So there are, as the sun sets, there are four important events that you should remember. Okay? Here is daylight, you can see the sun over there, and then as the sun sets, you have first the astronomical sunset. The sun sets. As the sun sinks down, the light vanishes very slowly from the sky. When the sun reaches an elevation of 6 degrees below the horizon, we have what is called civil twilight. It's the time at which you can no longer read a text outside. When the sun further drops to 12 degrees, you have what's called nautical twilight. Nautical twilight is the time at which the most important constellations are visible and you can begin navigating by the stars. This is the time at which you would launch a ship. And finally, when the sun reaches 18 degrees below the horizon, then the sky turns pitch black, and this is called astronomical twilight. This is the moment at which you can actually take a telescope out looking at stuff. Okay? So, at nautical twilight on March 18, 1178 BC, you would have seen the Pleiades over there immediately above the place where the sun was sinking. So as the sun sinks, the Pleiades retain for you the direction of sunset. Okay, you see, as the night goes through, you keep getting the Pleiades that barely move in the horizon a little bit, they move a little bit due north. Okay? So there is, from this time, 724, when the sun has, when you have the twilight, to 903, you can see the Pleiades and it's telling you the direction. On the opposite side of the sky, you have Arcturus. Arcturus is the brightest star in this little constellation called Bootes, or the Plowman. Okay? Arcturus is a very, very visible star. And it would just have risen as the sun went down. And then it would keep going up and up and up, and naturally it will set late. So please notice the relationship between these two groups of stars. One is coming down, the other is going up. Okay, like some kind of scale. Notice also that they are not exactly 180 degrees apart, they are a little bit less, and therefore there are two configurations. One in which Arcturus is rising and the Pleiades are setting, which is longer because the Pleiades are a little bit further. Can you see this line over here tracing the location of Arcturus? the Pleiades are a little bit to that side. If I were to center that, you would notice that it's not quite 180 degrees, a little bit less. So if you go instead to September, you would see the Pleiades somewhere here. What are the Pleiades? The Pleiades rising and Arcturus setting at exactly twilight. But it's a much shorter event because they are separated by, in this case, a little bit more than 180 degrees. You have this situation rather than this situation. And so, as they go down, clack, immediately one of them goes below the horizon. Okay? So, as the text tells us that he watched the Pleiades and late-setting Boötis, there is no question that there is only one time of the year in which you can see both the Pleiades and Boötis is late-setting, and that is March. Okay? Just, by the way, the equinox, the beginning of spring back then was on April 1st, not September 21st, so March was really late winter. This, by the way, over here is the bear, and you can see that the bear, as it goes around, it comes around the North Pole. This is, again, the horizon, and as it comes down, the little pieces of the legs just barely miss the horizon. And it doesn't actually dip. So these stars are not believed to be part of the smaller Homeric constellation. It barely dips below the horizon. Let me eliminate sunlight. And it never takes a plunge in the waters of the ocean. And indeed, the bear is always fixed looking at Orion. Okay, you can see that the direction of the Pleiades is always pointing to the direction of Orion. The Pleiades, the bear, is always looking at the place where Orion is. Okay? So let's get back to the talk. Let's go to the talk. Where was I? So we can go and do our math and see that there is a limit to the dates in which the constellations are seen as such. Okay? And this tells us that the new moon must be such that the new moon minus 29 days must be bigger than February 15th, and the new moon minus 12 must be smaller than April 15th, and we can embed those inequalities in a table. We can do the same thing with Venus. We can go ahead and compute. When is Venus visible high in the sky? When Venus is east of the Sun, it rises before the Sun, and therefore we see it in the morning. Okay? And the most eastern that it is with respect to the Sun, the earliest it rises. When Venus is west of the Sun, we see it trailing the Sun as the Sun sets, and we see it in the evening, and we call it the evening star. Okay? Half the time Venus is east of the Sun, half the time is west. But some of the time is so close to the Sun that we cannot see it, and therefore, roughly 1/3 of the time, Venus would be visible high in the sky before sunrise. Okay? Finally, Mercury is, like I said, the controversial piece of the story, but perhaps the most interesting. Mercury is described not as going to Ogygia in any linear path. He is described as coming down from Olympus and barely skimming the waves of the ocean. And then as he arrives to Ogygia, he goes on and on, moaning and wailing about how long he has had to come over here, and the only reason he did this is because Zeus really compelled him with the ages. Okay? And these two are very interesting to me. Okay? First of all, because it is not one of the traditional attributes of Hermes or Mercury that he should be close to the ocean, but really Mercury, because it's so close to the Sun, can never be seen far from the horizon. So this is a very interesting piece of the description. He really goes on about how he is skimming the surface of the waves. And finally, he's going on and on about how far west he's had to come. So what we take this to mean is, we take this to mean that Mercury, which moves back and forth in front of the Sun as the Sun is moving on the ecliptic, goes and comes back, and as it comes back, it makes what's called a retrograde motion. There are various events that we can call the initiation of retrograde motion, and they are all separated by, sort of 3 days. So we made a little table in which we look at one of these, and we said, okay, let's assume that on day TI minus 33, Mercury was within 3 days of making one of these retrograde motions. Okay? And this is indeed a much rarer event. There is a very enigmatic description of Poseidon sinking the raft of Odysseus. In this description, we see that Poseidon was coming from Ethiopia. In the beginning of the poem, Poseidon is in Ethiopia, which is generally taken to mean Egypt. Ethiopia means the land of the burnt faces. And he comes back, and from miles away on the Solymi mountain range, he spied Odysseus sailing down the sea and sinks the raft. And somebody, T.L. MacDonald, suggested that this might be related to the equinox. And in the beginning I thought it made sense, then people who know much more than me convinced me rapidly that this made no sense. But it makes sense, so that's why I mention it. Because it comes up in our dating that this does happen on the equinox. Okay? Now, the enigmatic reference to the Solymi is interesting. The Solymi are the Hebrew, the Jewish people. And so much so, Solymi, Soleman, Solomon, and so much so that according to Tacitus, Hierosolymi, the sacred sacred place of the Solymi, is the root of Jerusalem. Okay? How come, Poseidon was in Israel at the moment he sinks Odysseus' raft? I don't know what the reference means, but it probably means something. Okay? Finally, this is our table. So it's a lot of drudgery involved in doing it. You go through, you enumerate, a lot of moons. You look at them and you compute when is Venus up, when is not, etc., etc. And then you realize that all of these light green guys are good candidates for Venus. Light blue are mediocre candidates for Venus, and then for Mercury we have these good candidates and medium candidates and bad candidates, and as we intersect them we have 3 dates. One very good date, 16th of April 1178 BC, I think we saw that one before, and as a far second candidate, the 24th of March of 1157 and the 9th of April of 1191. Both of these miss some aspect. This one misses Venus being so high, and this one misses Mercury, by the edge. But the leading candidate numerically is April 16, 1178. So we went through these, we took references, spattered through the Odyssey. Okay? Presumably not the work of a single insertion. And we try to reconcile what the date could be, and we get exactly the same date as the eclipse. Now, our search range is 100 and something years. There's 365 days in a year. The chances that 2 different forms of dating give you the exact same day are 1 in 36,000. Okay? It's pretty slim. Right? So this is the revised chronology according to these ideas. We would have the date of the death of the suitor being these. On the 11th of April, indeed, Venus rose 1 hour and 40 minutes before sunrise. On the 18th of March, as I showed you before in simulation, the stars were exactly in the position as described in the poem. Okay. On the 13th of March, this is interesting, the day that Hermes is supposed to travel, Mercury appeared briefly for precisely 2 days. Okay? It was below the horizon, it appeared, it disappeared, and it appeared at its westernmost extension. I'm running over the edge already. I'm getting to 1 hour, so I should hurry up. But there's many other assorted references we could use. There's a lot more stuff in there that we could look at. In the opening, we're told that as the year drew to a close. Now, I didn't mention this before, but the eclipse is the first new moon after the equinox, and therefore, according to Hesiod, it is the new year. And when we are being told as the year drew to a close, is extremely literal. The day of the killing of the suitors is literally New Year's Eve. Right? The eclipse happens at noon, as described in the poem. There is not another eclipse in range, not even within 200 years, that happens at noon. Okay? What are the chances that, you know, the description and the eclipse match the hour, not just the day, but even the hour? Okay? In the beginning of the poem, there's numerous references to cold weather, which then turn to references to springtime stuff. So there's a beautiful reference of Odysseus telling Eumaeus that he has hid under much blossoming trees once he arrives in Ithaca. But before that, you know, there's plenty of references to cold and fires and using coats and so on and so forth. And Norman Austin made an extensive analysis of the theme of the swallow, because on the day of the killing of the suitors, the swallow, which is the harbinger of spring in, you know, most of the Mediterranean cultures, figures prominently. As Odysseus is killing the suitors, the string of his bow sang like a swallow. As Athena comes to witness the battle, Odysseus calls her to the side, and she says, "No, you do this." And she turns into a swallow and sits on the top beam of the Megaron. Okay, so there's a lot of different things that all of a sudden begin making full sense only when you have a specific date in mind. Even the negative ones, the absence of Mars. Ares is nowhere to be seen, mysteriously, you know, not in the epic at all in the foreground narrative. Mars is not visible in this period except at eclipse. And so on and so forth. So, let me conclude here, since I'm already way past my ending time. I conclude that there is a high likelihood that these four references plus the disputed eclipse reference all do refer to this specific date, and presumably that then this implies that all of them are by the same hand. You don't get random writers agreeing on a date by chance. How did Homer learn of all of these astronomical details happening 5 centuries before his time? I have no clue. We do not know. Did anything other than an eclipse happen that day? Was there an Odysseus? Was there any suitors to be slain? We don't know. Did Homer think anything happened, or he just made the whole thing up? We don't know. Okay, the only thing that we know is that in the sense of set that I described before, it appears to be that the Odyssey is set on this time. Namely, there are numerous references to a particular date that are all coherent with one another, but we cannot by this use it to infer anything more. That is the task of the other culture. And finally, I should mention that, yes, indeed, all of this is pointing to a big series of coincidences, but after all, still coincidences. Okay? And where do you draw the line? What is your threshold? At which point it is unsafe to neglect a coincidence further? It's a very personal decision. And I know extremely intelligent people who think that this is all just a coincidence. And I know extremely intelligent people that think that this is proof positive. And I don't think that the truth is, that black and white yet. And I urge you to go back home and pick up your copy of the Odyssey and read it and just ponder whether it changes the way that you read this. Because really, if we can change the way people see this most beloved classic, it's an enormous achievement for us. Okay? And I thank you for your attention, and happy birthday, Constantino. And I would very much welcome questions.
Have you tried to take account of whether the Ionian Islands were in a different place in 1178 BC than they are now? And to what have the Ionian Islands moved since 1178 BC, and is that a problem for you?
Have the Ionian Islands moved? Indeed, the island that we now call Ithaca was named Ithaca rather arbitrarily, sometimes after the Venetians re-inhabited it. It was uninhabited for a very long time. There is a gentleman by the name of Robert Bittlestone who claims he has found Homeric Ithaca. And interesting indeed, it's because they have moved, but vertically, the Kephalonian Peninsula was in ancient times submerged in the middle, so it was a separate island. And when you look at just that piece of the peninsula, it fits rather well the description that you find in Homer of being the one island further out to sea on the side of darkness, and so on and so forth. Still, the cluster of islands is smaller than the errors with which we can place the track of the eclipse. So I am not entirely worried about the islands themselves moving.
Are there any references to the wind that picks up when the eclipse happens?
The wind, yes. There are numerous. The wind is actually one of the characters in the background. In the background narration, Odysseus actually goes to the island of Aeolus, the god of the winds, whose children are the different directions of the winds. There is a very interesting passage. This is highly speculative. There's an interesting story there that Odysseus gets from Aeolus the bag of the winds. So he has literally harnessed the winds, and he goes back home with his sailors and soldiers. And just off the coast of Ithaca, the sailors commit mutiny, thinking that the bag of the winds actually has treasure that Odysseus didn't want to share. They open the bag of the winds are unloosed, and the ship again gets washed away from Ithaca after having been within sight of Ithaca. Now, there is a cycle to eclipses that's called the Metonic cycle, the cycle of 19 years that is thought to allegorically underlie the 19 years of the trip of Odysseus to Troy and back home. And this cycle has a sub-cycle that's a near miss. And when you look at this near miss, it coincides roughly, you cannot say because the background narratives are not dated to the day the way the foreground narrative is. They are dated, sort of to the year. But it would have happened in the year of the near miss. So winds might indeed play a certain role there. There are further issues with the wind, of course, as his raft is sunk. The winds were the west wind was meeting the east wind, and the north was meeting the south, so that effectively he was being tossed about and eventually capsized. Then there is another part of the story of the winds is the following. Hesiod, the only surviving contemporary of Homer that we know of, in Work and Days says of the heliacal setting of the Pleiades, which is the last day that the Pleiades are visible, that if you have an appetite for dangerous sailing, you should sail after the heliacal setting of the Pleiades, because gales of all kinds abound. The heliacal setting of the Pleiades is the date that Hesiod uses as a proxy for the equinox, and is in our dating the day before Odysseus' raft was sunk by way of gales galore. So it agrees, sort of exactly in that sense. The winds of early springtime were extremely dangerous for navigation, and they are very explicitly described.
In choosing the range of dates to search, you discarded Durus's estimate of the fall of Troy. If you expand your range to include that, do you come up with any other possible dates?
Well, yes, of course. I mean, if I expand the range, these events are such that you expect one good hit every 100 years or so. So you can't expand the range much more than a century without being sure to hit something. So it's what we call the false positives versus false negatives problem. So I expanded the range as much as we could without getting lots of, naturally if the range was, 10,000 years, we would hit 100 candidate dates. Now, whether those dates would also coincide with eclipses, that would be another matter, okay, and probably they wouldn't. But then I would have to assume the eclipse. So what Constantino and I set out to do here was to try to find the date independently of the lines of Theoclymenos, because there is one school of thought that says that those lines are apocryphal. So we tried not to assume them, okay, so as not to be left off the stage from the beginning, right? So we cannot extend the range so much.
I enjoyed that very much. I'm considered something of a positivist, which in the classics department here is not necessarily a good thing, but there it is. So one of my questions, well, a question is this. Getting back to Hermes, at what point in Greek literature does Hermes start equaling Mercury? And indeed, at what point in Greek literature do we start having specific names of planets?
Yes, so as you know, all of the identifications of gods with planets are Hellenizations of more ancient Babylonian associations, between gods having essentially the same character as their Greek counterparts. The first mention of Mercury in connection with Hermes is in Plato's Timaeus, who says of Mercury that it is the star we call sacred to Hermes. Actually, I think that the turn of phrase is more like, this is the star that we have always called sacred to Hermes, implying at least that the term was in widespread use at least at the time of his birth. So that sets us back to 432, if I recall correctly, BC, still at least 2 centuries from the latest dating that we would give Homer. So indeed there is a gap between Homer and the literature that would associate gods with planets. Okay, that is, on the other hand, there's nothing there either, okay, so we have neither positive nor negative evidence. But yes, indeed. On the other hand, there are much more indirect things we should take into account. The Homeric hymns which are older definitely than Plato, though we don't know whether they are really from Homer or from some contemporary Homer. The one for Hermes describes vividly an event where he swindled his brother out of his cattle by making the cattle go forward and then backwards, which is, I would say, a rather vivid allegory of the retrograde motion of Mercury. Mercury is, was the trickster because he moves back and forth and back and forth in the sky, and it's when you're actually watching it on the sky, it's rather eerie because it, from day to day, it literally jumps the place where it appears in the sky because of this retrograde motion. And the description of his tricks in the Homeric hymns is, quite reminiscent of these sort of tricks. Also, as I pointed out, in the Odyssey proper, there is an attribute of Mercury, never being far away from the horizon, that is vividly being described as an attribute of the character in the Odyssey. Namely, he has to go down, skim the waves, and only when he gets to Ogygia does he come out of the water, which is indeed the day in which it first became visible. So, there is some circumstantial evidence that maybe this Hellenization of Babylonian associations predates their appearance into the public literature, and may have been simmering in the underground before it was actually clearly described. Yes.
I wanted to ask questions not from the point of view of a classicist, but from the point of view of a scientist, looking at the way you approach this problem through this desktop astronomy software. So the thing that we know is that these events happen together, the ones that you've described happen together in 1178 BC.
Yes.
And we also know that Homer, or another guy of the same name, wrote the Odyssey hundreds of years later. So I wanted to pose three scenarios and get your feeling about what the technology of the time would have allowed. Okay, so one scenario is the extreme word-of-mouth scenario, which is an eclipse happened, a total eclipse, which was simply mind-blowing to the inhabitants of those islands, and people followed the sky very closely, and so therefore they knew empirically what all the other events were, and all those things were passed on orally, or however people pass these things on, and therefore that was a backdrop that Homer used to compose the Odyssey. So that's one purely empirical scenario.
Purely empirical scenario.
Okay, another
highly unlikely.
Okay, another scenario is people had the calculation abilities to calculate when all these astronomical events happened, including a solar eclipse, which is a pretty hard thing to predict, and so therefore we're able to back calculate the series of events.
Yes.
Okay, so the third scenario I wanted to play out was this. Hundreds of years before Homer lived, a total eclipse happened. And this is just simply mind-blowing, because who the hell ever saw a total eclipse? And they said, well, this is a story that gets passed down for hundreds of years, but what they can do is create a story around it, and the movements of the planets, I think, are easier to calculate because they are, more conventional recurring events. So I wanted to ask you, of these three scenarios, given what's known about the technology of the time, how would one rate these three possibilities?
So if you turn our paper 2 pages more, you will find at the end that we have exactly those three scenarios described.
Oh, good.
And we explain that according to our current knowledge, each one of them is more outlandish than the previous one. They are all equally unlikely. This is the problem we have with this dating. We have no good solution to the transmission problem. It poses, this dating poses more questions than it answers. And I think that that's good because it means that people should think. My personal favorite is the last one, namely that it was known that an eclipse was in the legend. Somehow that part got transferred orally. But by the time of Homer, there was already communication with Babylon. And you could, maybe Homer couldn't, but definitely the Babylonians could, back calculate these things. Okay, not only, so there's a very interesting weird coincidence, talking about coincidence upon coincidence, there are these recurrent cycles of eclipses, and one of them is the Saros cycle, the most exact of the eclipse recurrent cycles. And the Saros cycle is such that the position of Sun, Moon, and Earth come back to be almost in exactly the same position after the Saros, which is 17 years and 11 months, whatever, okay, except that the Earth has rotated 120 degrees. So you get almost exactly the same eclipse with virtually almost precisely the same track, but you get it 120 degrees somewhere else on the planet. If you wait 3 Saros cycles, you have a cycle called an exeligmos, and that cycle almost repeats the previous eclipse, displaced by a few degrees, so it doesn't really fall in the same place, but it falls not that far away. Now, the eclipse, one exeligmos after the eclipse of the Odyssey, was not only, which is in 1114 or something like that, the date is somewhere there, was not only total but maximal precisely over the city of Babylon. Okay, at a place where not only the technology to observe it, but the technology to preserve the observation was in place, and there is no historical problem of transmission. Okay, whether this is the link or not, I cannot say, but it's rather weird that this eclipse is connected to something that happened precisely over Babylon.
So it's like these Babylonian astronomers are like the Babylonian equivalent of Pixar, and they're able to do these calculations because they have the state-of-the-art technology for calculating these things.
Yes.
And what? And then the Odyssey is a prequel to the thing that they saw with their own eyes.
Could be. It could be that, it could be speculating that the structure of the Odyssey is a horoscope cast in reverse, cast backwards. So instead of saying, okay, let's cast a horoscope into the future and see what the future has for us, you say, I cast it backwards and I build a story around it. I don't know. It's just as outlandish a speculation as any. Okay, we could speculate all night long about the problem of transmission. I really, assure you, there is no easy solution. Okay, this is the big hurdle in this kind of research. All that you're seeing here, is telling you that you have to move the schedule for the contact between Greece and Babylon by at least 2 centuries before, our extant evidence. That part is, like I said at the beginning, the very good argument for those who claim that this is all just a coincidence. It's very hard to see how you could make it happen. Okay, I mean, I could come out with all sorts of, von Däniken aliens, UFO scenarios, okay, but that's not the goal here. The goal is to see how realistically this could happen. On the other hand, it might be too harsh to say that indeed the Greek were totally illiterate during the period. Commerce took place with various other regions, and there is no commerce that you can have without actually keeping sales note and receipts and the like. Okay, I mean, any kind of commerce that you do will require records. And therefore it's not entirely unlikely that there was some small specialized subset of people who could keep records during the time. I don't know. I really don't know, and it's far away from my field that this is completely speculation.
I have a completely unrelated question. Is there any mention of people going blind after the eclipse? Because if you stare at the sun without protection, you can go blind.
Yes, well, maybe that's how Homer went blind. So no, not that I recall. But it is indeed extremely dangerous to look at the sun after the eclipse. And indeed many people have gone blind trying to watch eclipses. But this is actually sort of a modern feature. Namely, we know that an eclipse is going to happen, so it doesn't sneak up upon us. Okay, we know it's going to happen, so people are trying to look for it, and they're saying, oh, did it touch? Is the moon there yet? Is the moon there yet? And they are trying to see the eclipse, and they literally burn, they touch the retinas by doing so. If you don't know the eclipse is coming, you're not looking. So you very properly said losing their eyesight after the eclipse. Namely, they were surprised by the eclipse, they are looking at it there, and then the sun comes out, and indeed they could lose their eyesight there. It's an excellent question. I'm not aware that anybody has described the phenomenon. But, sure.
My question is, how well does your placing of the date and the time at noon compares with the 5,000-year canonical catalog published by NASA?
How well does the
timing?
It's there, you mean the NASA site on eclipses. It's there. April, go look at it, you'll see the track.
That track does pass through the Ionian Islands.
Well, in the latest revision, so once again, the elements, technically speaking, what's called the delta T, the slowing down of the Earth rotation that you need to take into account in order to properly predict the track of an eclipse, is an irregular phenomenon. So in the time span in which we have abundant recorded and verified eclipses, which is from roughly 300 BC onwards, we can track the erratic motion of the Earth in rather good detail. Before that, we can only approach the envelope, what are called polynomial approximations to delta T. Those get revised every other year. And the catalog that you're describing, Fred Espenak's canon, 5,000-year canon, Espenak and Muse actually, canon of solar eclipses, they are forced to revise the polynomial approximation of delta T every now and then. Okay, every time they do that, our track is going to jump. Okay, but even then, even as they do that, the earliest eclipse used for the dating is not going substantially far back, so the error is not being reduced. So we have a large error, and this guy is, sort of jumping with a fairly large error. So, what you're going to do? We have no better numbers than that. And unless, massively people turn out to go and, dig for Babylonian tablets and get dating of eclipses, which is sort of hard with the war going on there, what you're going to do? I mean, that's the data we have. Okay.